Hi, this is a brief video going through a non-calculator paper. So it's going to be approximately 15 minutes, which obviously the workshops will be longer and you'll have a chance to answer questions. If there are any questions arising from this video, do feel free to contact me. Okay, so this is a non-calculator paper. So obviously that will adapt how you approach the questions. A non-calculator paper for Edexcel at level 2 is 25 minutes. So it always comes first in the test. After that 25 minutes, it will shut down or be taken away from you and you will not have access to it. So there is a time consideration to think about as well. So we're going to look at 3 of the 4 questions. I will do the 4th question, but I'll do that separately in a separate video because I don't want to rush it, and obviously these have a limited time span, so that will come in a separate video and a separate link. So let's have a look at the first question. So as I've mentioned in the top tips, and as we always say as we're going through any sort of maths workshop, it's really important to read the questions. So some of these, couple of lines, obviously not so important, but it will be vital in the longer questions. So first one, work out 700 minus 7, and that little 2 means squared. Important to look at is that this is a 2-mark question, which would sort of indicate that there are 2 steps to the working out, and I think there are. Only the 1-mark questions, and there's one coming up, only really has 1 step. So a couple of things for this. So work out 700 minus 7 squared. So the important thing to realise straight away what 7 squared is, and you can put this down. I'm sure this is why it's a 2-mark question. So 7 squared means 7 times by itself. So 7 times 7 is 49. Okay, so again, the non-calculator part of it is really testing a little bit of times tables. It probably will go no accident that it's 7s, because that's a hard times table or something that some people don't know very well. So 7 times 7 is 49. So that's the first step of it. So it's work out 700 minus 7 squared. So it's 700 minus 49. So again, we have to have non-calculator techniques to work out 700 minus 49. So again, there are lots of different ways. It's not too bad a way, because one way you could do it is to round it up to 50. 700 minus 50, we're okay with that, I think. So that's 650. Remembering to then add on the extra 1, so 651. But again, if you can't immediately see that, sometimes the pressure of exam techniques and exams, you have to think a little bit further or think a little bit differently. So you can do this long or the column subtraction. If you're doing that way, it is quite a tricky one actually, so it probably would be better just to round it up. But okay, so let's go through this quickly. So 0 minus 9 you can't do, so we should know what we have to borrow from the next column across. So we go to the 0, and again we can't do that because we can't take away from 0, so we have to go to the 100. So we're borrowing effectively 100. So we first put it in the tens column. So 10 hundreds are 100s, but we need it in the units column. So we are going to borrow 1 from that. So that turns it into 9. And then we can actually do the sum now, because it's 10. So 90 plus 10, that's where the 100 is made up now. So 10 minus 9 is 1. 9 minus 4 is 5. And then 6 minus none, so it stays as 6. So it's 6, 5, 1. So again, that backs up with our initial theory as well, but it is a good self-check. Okay, so moving on to the next question. Let me move it up so it's actually in the screen. here is a list of numbers. So 29, 31, 46, 43, 29, 31, 38, 34, 43, 35 and 43. The question is asking us write down the mode of these numbers. So again, a bit of technical term there, you do need to know what mode is. So mode is a form of averages, which in itself is a form of statistics. So there's three forms of averages that we do cover in the course. Mode is one of them. Mode means most common number. So really what we're looking for is the number that occurs the most in this instance. So having done this before, I know that it's 43. So again, it's worth looking and also double checking, because again, an exam situation, you might not be thinking as clearly or as usually as normal. So there are 3 43s. No one else gets to 3. So the answer here is 43. Remember, mode is most common. Okay, so let's go on and have a look at the next question. So again, you can see that it is getting a little bit longer in questions. So it is really important to read them, not just once. And if you notice while I was doing it, constantly referring back to the question as I was asking you, that is what you're going to have to do. So let's read the question. Ola will run from her house to a local park and back to her house. She sees this sketch of the route she will take. So we've got a sketch of the house, 1¼ miles to the park, and then park back to the house is 2¾ miles. So again, we're working with fractions. We do a lot of work on fractions, decimals and percentages. They will throw fractions in wherever they can. So question is asking us, what is the total distance of the route Ola will run? Give your answer as a mixed number. You must show your workings. Again, 3 marks, quite a high amount of marks for this question, I think. But again, I think it's reflecting that people do find fractions, and this is adding fractions, pretty tricky. So if you find it difficult, most people will find it difficult, and you will get rewarded for any work you put into try and understand it. The other thing that's not obvious is the definition of a mixed number. So again, probably do need to know it. I'm sure you could probably guess it actually in this occasion, but a mixed number is a number that's got a whole number and a fraction. So the actual maths in the question is mixed number. So it's important to keep it in the same vein. If you're not expressing it as a mixed number, you're not getting all those marks. So we have to add up. So going back to the question to find out what we do need to add up. So it's 1¼ plus 2 3/8. So again, lots of different ways to do this. In this video, I'm only going to explain once. If you do want to know a different way of doing it, please contact me. So what I'm going to do here is add the whole numbers separately. Okay, again, we could turn it into an improper fraction and add it up that way, but again, I'm not going to do it. So 1 plus 2, and I'm going to put it to the side here because I'm going to come back to it, is 3. Okay, so what we're left here with is adding up the fractions. And again, the trick here, or the maths here, is that we can't add those fractions unless we put the denominator to be the same. So again, this is a stage in which you have to do. So we are going to turn quarters into eighths. It's going to remain the same number. It's going to be equivalent. If we change it into a different number, we're not doing the sum. Okay, so a quarter into eighths. So how we do that is that we are going to turn it into 8. So the bottom number is going to be 8. Okay, so we've changed that bottom number to an 8. We want to keep the fraction the same, or, you know, the sum just doesn't make any sense. So what we've done to the bottom number to change it to an 8 from a 4 is times it by 2. So we've got to do exactly the same to the top number. If we don't do exactly the same, it becomes a different number. It's not equivalent. So we times 4 by 2, we need to times 1 by 2. Okay, so now we can actually do that sum. Okay. Just realised that I've written out a question wrong. So again, as I always say, mistakes are good if you pick them up, but that's why we check, because mistakes will happen. Okay, so it's 2/8 plus 3/8 now. So we keep the bottom numbers the same. When we're adding, add up the top numbers. So the fraction part of it is 5/8. Okay, so not ignoring the whole numbers. So the number for the whole question, got the 3 there, got the 5/8, is 3 5/8. So again, show the working. That is the working. We have done the working now. And obviously where it says to put the question is where you need to put the question. It's being a bit difficult, but there we go. Let me move it up. Okay. So it should stay there now. So the answer to that is 3 5/8. Okay, so on to question 3. So let me read out the question. Salma is making a filling for a cake. Salma mixes jam, sugar and soft cheese in the ratio 4:1:16. So we've got the ratio sign there. She uses 32 ounces of soft cheese. Salma knows that 1 ounce is 28.3 grams. How many grams of jam does Salma need? So again, it's sometimes, and I've had conversations with people recently, some of the hardest things is to even start what sort of maths this is, or what sort of skills you need to master to answer the question. This one is telling you basically it's ratio, which doesn't always happen. So it's a ratio question, and there is also a element of changing metric to imperial, because we've got ounces and we've got grams. So we've got 2 different skills that we have gone through combined in the same question, and it's a 3-mark question. So again, what I always do when I realise it's a ratio question, and again this is a ratio question, it's fairly obvious, is I start to rewrite the question really, because I find it easier to decide the steps there. So 4:1:16, literally just copying it out from the question. But I also put in a slightly different way, a bit more visually, what else I know from the question. So you've got to always keep the items in the ratio in the same order. So I make sure that I do that by putting the initials, in this case, whatever you need to do to make you remember that underneath it. What we also know is that when applying the ratio, so this is the ratio of things keeping in proportion. When you apply it, you don't always just want 16 bits of it, 4 bits, 1 bit. You can adapt it. So they've adapted it to 32. So at this point, especially on this course, we've got 2 different methods for ratio. One is what I call proportion, one called parts. This is a proportion question. We need to keep things in proportion, and this is what it is prompting us to do. So if we keep things in proportion, we've got to realise what's happened to the 16 to the 32 and do it in exactly the same way. So it's been times by 2. Another way to work out is to divide 32 by 16, and that gives you the answer. So that is the rewritten ratio, keeping it in proportion. So I do realise I'm running a bit out of time, so I will skip to the end of the question. So what we need to do now is they want to know how much jam is being used. So we know the ratio number is 8, but we need to convert 8 ounces into 23 grams. So it's giving us the conversion factor, which is 28.3. So again, it is a non-calculator paper, so there is sort of methods to do that. Running out of time, so I will tell the answer, which is 226.4. The next bit says use estimation to show a check of your answer. So they acknowledge that that's quite a difficult mental arithmetic question. So perhaps you would do it in a different way. So it could be 8 times 30. The estimation is with the 30. So the bottom number as an estimation could well be 240.